Resistance is a property of a material that opposes the flow of electric current, making it harder for electrons to move. The unit of resistance is the ohm, denoted by the Greek symbol omega, named after German physicist Georg Ohm. In a circuit diagram, a resistor is represented using this symbol. Electrical current is the flow of electrons through a conductor. Resistance is anything that slows this flow. You can think of resistance like water flowing through a pipe. In a wide, smooth pipe, water flows easily, just like current in a material with low resistance. In a narrow or rough pipe, water flows more slowly, just as high resistance slows the flow of current. Ohm's law explains the relationship between voltage, current, and resistance in a circuit. It can be written as V equals IR, where V is voltage in volts, I is current in amperes, and R is resistance in ohms. Higher resistance requires more voltage to achieve the same current, while lower resistance allows current to flow more easily. Resistance depends on several factors and can be calculated using the formula R equals ρ times L over A, where ρ is the resistivity of the material, L is the length of the conductor, and A is the cross-sectional area. Resistance increases linearly with length and decreases with cross-sectional area. In most conductors, resistance also increases with temperature because atoms vibrate more, making it harder for electrons to flow. This principle is the reason why superconductors are able to have zero resistance at extremely low temperatures. In series circuits, the total resistance is the sum of all resistor values, while in parallel circuits, the total resistance is found using this formula, where the inverse of each resistor value is summed. From this, we can determine that adding resistors in series increases total resistance, while adding resistors in parallel reduces total resistance. For example, two 6.7 ohm resistors in series give a total resistance of 13.4 ohms, while in parallel, the total is 3.35 ohms. The resistance of elements in real-world applications is very important. As current flows through a material with resistance, some energy is converted into heat. For example, the high resistance of the filament in an incandescent bulb causes it to heat up and glow. Most other applications, such as electrical cabling, prefer low resistance because it allows electrical current to flow more efficiently, reducing energy loss. Thanks for watching.